In this video, we are going to do these, how many? 5 questions, which are based on, primarily based on these two property, that radius is perpendicular to the tangent at the point of contact. We'll also be using the property that perpendicular drawn from the center bisects the chord, including some exterior angle property over here and applying Pythagoras theorem over here, and the isosceles property that angles opposite to equal sides are equal. So let's begin with the first question. In this question from this circle, which uses these two concepts or the properties, that is radius is perpendicular to the tangent at the point of contact, another that the perpendicular drawn from the center bisects the chord. Now let's begin with the reading the question. Here says that PB is a tangent to the circle with center O to B. So we can say that this is PB is a tangent and B being the point of contact. The center of the circle is mentioned as O over here. Further, it says that AB is a chord whose length is given 24 and it is at a distance of 5 centimeter from the center. So this length AB of the chord is mentioned as how much? It is given as 24. So let's write it down. This chord length is 24. The length of this chord is 24 and this is given as 5 centimeter. Now you should understand the distance word. Distance of a line from a point has to be perpendicular. So by default, this is 90 degree. Now what we have to find out, there is one more thing given, is the tangent is of length 20 centimeter, right? We know the length of the tangent as well. This is given as 20 centimeter. The length of the tangent, that is PB. What we have to find out is the length of OP. Well, this length is what we have to get. This is OP. Now to find this length OP, what we are going to do is to draw one construction, and the construction will be joining the center with the point of contact. This is what we have joined here. Now what we know, the first thing that, as I said, that we are going to use this property, that is perpendicular drawn from the center bisects the chord. So we can say that the length of AM should be equal to BM. As I said, perpendicular drawn from the center bisects the chord. So therefore, since the whole length is 24, each will be 12 centimeter. Now, once we get the length of this, we are going to apply Pythagoras theorem in this triangle, and the triangle here is this. Right. So we know that the square of the hypotenuse here is what? OB. So the square of the hypotenuse is equal to sum of the squares of other two sides, that is OM square plus BM square. So OB square, the length of OM is what? 5 and BM is how much? 12. You know that 12, 13 and 5 is a Pythagorean triplet. So we can directly write this length as 13 centimeter. So we got this as 13 centimeter. Now check, this time we are going to take this triangle. Again, we are going to apply the Pythagoras theorem. So let's say triangle is this, right? So here we are going to first use the concept that radius is perpendicular to the tangent at the point of contact. So this angle is going to be 90 degree over here. Now if I apply the same concepts, that is Pythagoras theorem here, we will get the length of OP. So OP is what? You know that the line opposite to the 90 degrees is the hypotenuse. So by default, OP is the hypotenuse. So square of the hypotenuse is equal to sum of the squares of other two sides. So it's going to be OB square plus BP square. OP is what we have to get. Length of OB is 13. So it's 13 square. And length of BP is how much? 20. So OP square should give you, this is 169 and this is 400. So the length of OP will be what? Under root of this. So it's coming as 569 under root. We know that it's not a perfect square. Moreover, we should know that this under root 16 is not a perfect square. So we can leave this answer in centimeter. Now in this question, it says OP is a tangent to the circle with center O at a point P on the circle. So let's begin with making a circle and a tangent. So I made a circle over here, and then I'm going to make a tangent, this being the tangent to the circle, and the tangent is drawn from a point, external point is Q, as I can see, and P is on the circle. So P is this point. Now further, if I read, it says that, well, it's also given O being the center of the circle. Let's say O being the center of the circle. It says if triangle OPQ is an isosceles. So we need to join this also. That means if I join this, all right. Now this is a tangent, point of contact joined with the center as well. Okay. Even if it does not look like an isosceles triangle because they are not drawn up to the scale, right? So we'll be taking it like this only. Question is, this is an isosceles triangle, not the question. Information is that this is an isosceles triangle, right? So what we have to determine in this case is to get the value of angle OQP. This angle is what we have to get. OQP is this angle. Now what we know that radius is perpendicular to the tangent at the point of contact. So this angle is 90 degree. Okay. And we know that therefore OP is the hypotenuse and hypotenuse is the longest side. So in an isosceles triangle, if two sides are equal, has to be the sides other than the hypotenuse. So by default is going to be OP is equal to PQ. These two sides are equal. And what we know that in a triangle, if two sides are equal, isosceles triangle property, then their opposite angles will also be equal. So these angles, say angle Q will be equal to angle P. Now check, it's a right angle triangle, and in a triangle, if two angles are equal and one is 90, the other two has to be 45 each. Okay, so we can say that this angle will be 45. One more time, we know that sum of three angles of a triangle is 180. Let's say if I say that these two angles are x, so by angle sum property, x plus 90 is 180 degree. That means 2 times x is equal to 90. This implies x is going to be 45 degree. So we had to find angle this OQP, and that is angle Q only, and Q is how much? 45 degree. So we have an option, that is B is the correct option in this case. In the next question, we are given a figure over here, and it is given that PA is a tangent to the circle from an external point P. So P is an external point from where a tangent is drawn, and clearly A is the point of contact over here. And the center of the circle is given as O. We are also given the value of angle PA. That's what the angle given here is POB. This angle is POB, and it is how much? 115 degree. So we know this angle of the at the center. Now what we have to find out is this angle, that is the angle we have to determine is this angle is what we have to determine, that is APO. So this seems to be very simple, like what we know that this is 90 degree. The reason is radius is perpendicular to the tangent at the point of contact. And in fact, we can apply the exterior angle property to get this angle. So this angle, that is angle P plus this angle, which is 90. You know that exterior angle of a triangle is equal to sum of two interior opposite angle. So angle P will come as how much? 115 minus 90. So that is angle P is 25. Yeah, 25. So yes, this is A is the correct option. Alternately, you could have applied linear pair. You could have applied linear pair to get this angle, and this being 90. So by angle sum property, you will get this as 25 only. The next question is given that O is the center of a circle and PQ is a chord to the tangent. So we are given PQ is a chord and this PR is a tangent to the circle, and the point of contact is P only. And further, it's given that the angle made by this tangent and the chord is 50 degrees. So this angle is 50 degree given. What we have to find out, is angle POQ. Yeah, this angle is what we have to find out, POQ. Now what we are going to do here is the property that radius is perpendicular to the tangent at the point of contact. So this angle is 90 degree. One more time. We know that radius is perpendicular to the tangent at the point of contact. So this angle is 90 degree. So what will be the value of this angle? That is angle OPQ should be how much? 90 minus 50 degrees. Should be 90 minus 50, and how much it is? 40 degree. So now we know the value of angle OPQ. So we can write it over here that this angle This angle is how much? 40 degree. Further, what you can see in this triangle, right? This is an isosceles triangle where the two of its sides are the radii and they are equal. That means OP is equal to OQ. So therefore, what we know that angles opposite to equal sides are equal. So this angle will be 40 degree. Right? That you have to write in the examination if it's not an MCQ. Now further, we have to find this angle. So how do we get this angle? That's by angle sum property. So this angle, that is POQ, which we have to determine, will be 180 minus sum of the other two angles, that is 40 plus 40 is 80. So this comes out to be 100 degree is the answer for this question. In this question, we are given a figure with O being the center, and ln is the diameter, this being the diameter of the circle. Further, we are given PQ is a tangent to the circle at point A. So PQ is a tangent and K is the point of contact. Now we can see one more angle is given, that is KLN. The length of this, the measurement of this angle is 30. What we have to find out is angle PKL. That is PKL is this angle. Yeah, we have to get this angle. Now, what we know here that look into this triangle, you can see that we can apply isosceles triangle property. And why should it be an isosceles triangle? We can see that these two are radii. OL is equal to OQ is the radii. So what we know that angles opposite to equal sides are equal. So this angle is going to be 30 degree, right? And what we know that radius is perpendicular to the tangent at the point of contact. Radius is perpendicular to the tangent at the point of contact. So this whole angle is how much? 90 degree. This whole angle comes out to be 90 degree. So in order to get this angle, that is angle PKL, it should be what? 90 degree minus 30. So that comes out to be 60 degree. Yes, its answer will be 60 degree in this case.